Right, greetings. So, I was going to look at exercise 8F, part 1, a little question about Abby's morning walks. Abby goes for a morning walk as long as the temperature is not too hot and not too cold. And then she meets Goldilocks. No, that's not in there. Okay, the morning temperatures are normally distributed. The mean is 20, standard deviation is 5. I'm going to write that down because that sounds important, doesn't it? We're going to need that surely. So this is 8F1, and I'm doing question 10. We've been given a mean of 20 degrees for the morning walks. The standard deviation is 5 degrees. Okay, back to the question. The lower limit of Abby's walking temperature is 11. She goes for a walk 95% of the time. The upper limit's unknown. That's what we need to find. Let's draw a picture, which I strongly recommend doing for a lot of these questions. Right. So our variable x, that can be temperatures. Let's try and draw a normal distribution that doesn't look too dodgy. Whoa, that's pretty bad. Okay, so means at 20, standard deviation would be 5, so 15. Within 2 standard deviations is her lower limit. Right, at 11, she has an upper limit that's unknown. I'm going to call that K. So in this region, we've got 95% of the area. We don't know what these outside areas are. I mean, I know they've got to be less than 5%. There's nothing telling me that this is that this area is in the middle, right? So I can't assume that that's 2.5% there. I would have to work that out. Some notation, we could say let variable x be temperatures. We could say that this x is distributed as normal with mean 20. I don't need the degrees really. The variance is 5 squared, right? If I knew this little area here, I'd be able to find out K because I could work out that area plus this area, 97, 98, 99, whatever it turns out to be, and then I could do inverse normal on my calculator to find out the K for a given area, right? So we need to work that out with normal CDF. So we could say the probability that the temperature variable is less than 11 degrees. That's normal CDF to find probabilities. Right. You need a lower, make it as small as you can. You need an upper, 11. You need the mean and the standard deviation. So let's whack that into a calculator and see what number we get. Oh, look at that. Now, if you're wondering or if you've forgotten, here's your calculator screen. You press second, distribution. We're going to the normal cumulative density function. We're setting the lower super low. Our upper will be 11. The mean's 20. Standard deviation 5. And we get 0.0359. Write that down. Approximately 0.0359, right? So the probability that we're less than k, that would be a combination of this one, that we're less than 11, plus this probability that we're given, where the x lies between 11 and k, which is unknown. So that we've just worked out. It was 0.03359. This one was 95%, 0.95. So whack them together and you've got 98.59% or 0.9859. And I can use that probability to work out this k using inverse normal, right? So therefore, k equals inverse norm function. We'll need the area. We'll need the mean and the standard deviation. So let's have a look at that in the calculator. So I go same thing again, second dist inverse normal, 0.9859, mean 20, standard deviation 5. Now I'm just going to keep this on left. Newer calculators, you get the option. Older calculators, the default is left and you don't get to change it. So that just means, what's the answer? 30.97. I'll show you on the picture. 30.97. I've got to remember that. Okay, so from the left means from the left of the curve up to where the k is, right? And it was 30.97. And we're done. 30.97 degrees. All right. Now, I'll just go back to the question in case there's a part 2, but I think that was it. Find the upper limit. Yep, all done. Okay. Great job. Over and out, people.